Hello guys, welcome back to the channel. So today in this video, we are going to discuss about chi-square. So first is first, what is chi-square? So basically chi-square, it is a method to check how efficient are two data sets. How efficient are two data sets, namely observed data set and expected data set. So basically chi-square is a method used to check how the given observed data and the expected data were related to each other. That means whether they were efficient enough to prove both are same or not. So we can calculate that using chi-square. For example, let me take an example. So here maybe I can take some expected data as and here I may take observed data. So maybe let us consider that these were the ticket prices at a cinema theater. Maybe we can take 150, 200, 150. So let us consider that these were the ticket rates which were found in a movie theater, but someone came and told that the expected ticket rates. That means we know that someone told us that these observed ticket rates were seen from the theater, but some other person came and told us that expected rates are like this, 125, or maybe he told that all the average is 125. The average rates is 125 and observed is 150, 200, 150. These were the actually observed details of the ticket prices in a theater which were told by a person, and these expected prices were told by another person where he told we can expect this much of price per ticket. So that's why I have taken expected tickets and observed ticket rates. So while calculating whether both are efficient to each other, or that means whether we can estimate that expected rate is almost equal to observed rate or not. That means is it efficient enough to prove that expected rates can be nearly matched to observed rates. We can use a formula using chi-square that is called as. So for this we are going to use chi-square formula, which is going to be O minus E whole square divided by E, where O is nothing but observed data and E is nothing but expected data. And also we have to do the summation from I equal to 1 to n. So based on this formula, if we want to calculate the chi-square and we have to predict whether we can get efficient data or not. So first of all, what we have to do is, first of all, we have to calculate this chi-square value, and with respect to alpha value, that means significance, we have to find the chi-square value of this particular chi-square value which we get here. So using that chi-square value which we are calculating, we have to go to chi-square table, and using degree of freedom and this alpha, that means sigma significance value, we have to find out the actual chi-square value from the chi-square table, and we have to compare that chi-square table's value with the value which we got from this formula. So if it is really greater than the value which we got from this formula, then we can consider that the data is significant with observed data. That means both the expected and observed data were significant to each other. But if the value which we got from chi-square table is really lesser than the value which we got from this formula, then we can consider that expected data is significantly different from observed data. So first of all, let us find the value of observed minus expected whole square by expected. So if I do the observed minus expected whole square, so here 125 minus 150 whole square, which is going to be 25. And again, in the second point, we have 125 minus 200 whole square, that is going to be 75 whole square, which is going to be 5625. And in third place, we have 125 minus 100 whole square, that means 25 whole square, which is going to be 625. And again, here we have 125 minus 50 whole square, that means 75 whole square, which is going to be 5625. So we got the values of O minus C square, but now we have to divide it with E. That means these values, that means 125, 125, 125, and 125. So if I do so, I will get the values like O minus E square divided by E, which is going to be 625 by 125, which is going to be 5. And then 5625, which is going to be divided by 125, which is going to be 45. And then 625 divided by 125, which is going to be 5. And again 5625, which is going to be divided by 125, which is going to be again 45. So these are the values, but in the formula we have to do summation of I is equal to 1 to n. So we have to add all these numbers, then we will get the value called as 100. So we got O minus C whole square by E as 100. So now what we want to calculate is we want to get the value of n. So what will be the value of n? So basically here we have 4 data points, so that's why n is going to be 4. So here we have calculated O minus C whole square divided by E equal to as 100, and n is equal to 4. So in order to do the calculation, first of all, let me draw the graph and I will show you what we are going to achieve or what we are being expected to achieve. So for example, let me take this as my graph and I will take the data spreading maybe like this. So after taking this spread of data, so actually we have taken that this significance value is 0.05. That means until the point here we may have 95% of data, and this is going to be 5% of data, which is going to be 0.05 significance value. So this is going to be my accepted value, and this is going to be my rejection area. That means if I get jet table value after this position, after this particular position, then we can say that two given data were not significant to each other. So first of all, we have to find the value at this position. So in order to calculate that, so we can calculate it from chi-square table, and to calculate it, we first need to describe what is degree of freedom. So we have degree of freedom formula as n minus 1. Here n is 4. So 4 minus 1, which is going to be 3. So we have degree of freedom as 3, and our alpha is going to be 0.05 as given in the question itself. Usually these kind of data, that means alpha data, that means significance data, will be given in the question itself. Now with respect to degree of freedom 3 and alpha is equal to 0.05, we are going to see the value, that means critical value. So with respect to degree of freedom 3 and with respect to the point 0.05. So here we have a value called as 7.81. So my critical value is going to be 7.81. So now what we have to do is we have to compare this 7.81 with the value which we obtained from the formula summation of I is equal to 1 to n o minus e whole square, which is going to be divided by e. We have to compare 7.81 and 100. Here clearly we can see that 7.81 is really less than 100. So as an output of hypothesis testing, we can simply tell that we can consider expected data is significantly different from observed data. So here why I am telling it is significantly different means there is nowhere comparison between this 7.81 and 100. That means we got 7.81 here, but we may get 100 point maybe at this position or even after. So as this 90% of the area is only going to be our acceptance area, so all the data which is in all this way is going to be my rejection area. So we can consider it as we can consider the problem statement, or we can declare the conclusion as we reject the null hypothesis and we have to go for alternate hypothesis because both the data sets which were given were significantly different. So this is all about today about chi-square. So now in the next video, I'm going to teach you about F-test, which is going to be the last video of our playlist of statistics for data science. So if you haven't watched all my previous videos, I had given the link in the description to the playlist where you can learn statistics for data science. So hope you will watch those videos also, and thanking you. Let us meet in the next video.